Now we are back with the time for the next talk by Mikhail Bashurov, and it will be about bending the reality with type-directed Emit. So please welcome Mikhail to the stage. Hey, Mikhail, welcome. How is it going?
Yeah, hi, folks. It's going great, actually.
So
How
I
are
see
you?
in the chat that you are currently into Cyprus. So that means I see that there's even like some surfboard behind or something. Is that correct?
Yeah, it's not like there's a lot of surfing in Cyprus, but if you get a good weather forecast, you can have it, in some way or another.
Sounds pretty good. And I see that you are self-proclaimed type theory compiler wannabe. So my question is like, how many compilers or like finished or like half finished or just tried out like are lying around your hard drive or like your open source repositories? Do you have a count?
Well, I'm not that I do the compilers myself, but I have some contributions to the TypeScript compiler, to the ReasonML compiler. So I do this stuff from time to time, and I'm interested in, in the undergoing of the stuff, the deep understanding of it.
So basically, we are all using stuff which you provided us with, at least in a small part.
Yeah, it's pretty
Fair to
small.
say,
Yeah,
yeah.
but still.
But everybody is using your stuff. Perfect. So anyway, let's not delay any further and jump straight into the topic, please.
Yes. So my talk is titled Bending Reality with Type-Directed Emit. What does it exactly mean? So what it means is that I'm going to talk a lot about TypeScript itself, but not in the usual sense when you hear a talk about TypeScript. So this TypeScript is great. You can do these things. You can do these things. I'm going to take a type and try to somehow affect the emit based on it. What does it mean? So the types and TypeScript are subject to a thing called type erasure. Basically, it means that if you write an interface or a type, and then you compile or transpile it, whatever you call it, it just disappears. It's gone. It doesn't affect compilation in any way. It only affects your editor, your auto-completion, this kind of stuff. But they're just erased, and that's it. Of course, there is some things that somehow affect the compilation, but they are in the JavaScript itself. For example, classes are in JavaScript. And so if you write a class in a TypeScript, it will be as a class in JavaScript, only the access modifiers will be stripped off and the type, obviously. But what if we somehow can affect the emit or the compiled code with the type? So we bend our reality, which is runtime code, with the types. So that's I'm going to talk about. Well, as tradition suggests, a few things about me. My name is Michael Bashurov. I worked more than 10 years in IT industry. In the last 5 years, I worked with modern front end, mostly with React and TypeScript, but I also feel tender love to ReasonML or REST scripts and to functional programming approaches in general. Right now, I live in Cyprus and work at a company called WiseBits. And my hobbies would be, obviously besides programming, running, yes, surfing, as you can see, music, I play drums, and video games. Yeah, and learning foreign languages. But okay, enough about me. Let's talk about JSON validation. So, JSON validation, it's been a thing for a long time. Why is this actually, some problem you want to approach? But the first question I'm going to answer, why you need JSON validation? Because what's even the point? You can just write types or write tests. So, for instance, let's imagine we request a JSON from the server. and we get the JSON, and it's valid, and it's good. We get the bold man. Everything's great, application working correctly. But then after some time, we request the same JSON, and we get the bold man, and it's valid. But something's off, something's wrong with this picture, because it looks like a bold man, but it's not the same thing as we requested earlier. Something is wrong. What could be wrong, actually? For example, some field in the JSON can be missing, or some fields that it is required to have an integer have a null, or part of an object is missing, or instead of a number, we get a string with a number inside. And so in this case, a lot of things can go south. For instance, the application would work incorrectly. So the user clicks something, but nothing happens. Or the application could crash, or maybe in some rare cases, even the tab could crash. So most likely something happened, and most likely it will be bad. So we want to do something with it because we got a big JSON from the server. Okay, maybe we need to validate it. Okay, let's validate. But after you validate, what you gonna do? So you validate the JSON, and then you got an answer. Okay, it's invalid. And so what? So what we gonna do? I can imagine three things you can do in this case. First of all, I guess it's the most important one, is to log an error. Why is this important? Because imagine you don't have a JSON validation and you don't have this error logging of the JSON coming from the server, which is invalid, and you get an error in your, I don't know, Sentry, rollbar, ELK stack, whatever. You have a logged error, and you see cannot execute function to fixed. And maybe you even have a stack trace, so you understand exactly where is this happen, but you don't understand why. Because, why this could happen? So you try to debug it, try to reproduce it, and finally you end up, instead of a number, I have a string. So it doesn't have a toFixed method. And then you need to understand where from this data came, why there is a string in here instead of a number. And then you reproduce it again and again, and finally you get to the understanding that the bad data is coming from the server. Something is run on the backend, for instance. And so you spend a lot of time to understand a very simple thing. So the data which you are expected is invalid. So if you will get the same error, cannot execute function to fixed, but then on the somewhere up, you have an error, this data response from the server is invalid. You will have much easier time understanding what is going on. So logging this kind of stuff is the most important. The second thing is, in some cases, you want to just fail. If it's some mission critical path, for example, user is spending money, you may want to just fail if the response from your payment provider is not what you're expected. Because imagine a user trying to buy something and it presses spent my money, and then the money is spent, but nothing happens afterwards. He may want to press again or something like this. So if we just fail because something is clearly wrong, we may save some in some ways the user. But of course, it's not for all cases, and the rarest occurrence would be to recover. So in some rare cases, you understand, the data is invalid, but I know just the right way to recover from it and then continue working. It's exactly one example I've experienced, in my work, where the the response from the old versions of the service would exactly have the numbers inside of a string instead of just a number. And so we converted some of the string to the numbers in this case. But as I said, it's a pretty rare occasion. I guess I somehow convinced you that the JSON validation is the thing and you need to do it. So let's do it, right? Okay, we have this pretty simple JSON. It's a to-do list item. It has a title and an ID. Title is a string. ID is a number. That's it. It's really simple. So let's try and validate it. The first thing, of course, we need to do is to parse it. So json.parse. The next thing we want to do is to catch an error, because if the JSON is malformed, for example, it doesn't have an ending quote or something like this, it will throw an error. So we need to handle it. Okay, try catch. Great. The next thing we want to check that this JSON is actually an object. So it's not a string, it's not a Boolean, not a number, not a number. So if it's not an object, we throw an error. Okay. I guess if you remember, the type of null or undefined would also be an object. So we need to check for that. So we check that the JSON is truthy, because we already checked that it's an object. So only an object would work in this case. Yes. And finally, we're getting to the fields, to the actual fields of an object. We need to check if the field title is present, that its type is a string, and it's not empty. And we need to do the same stuff for a number. So it's not number, for an ID. So the ID is present, it's a number, and it's positive and non-zero. So as you can see, it's a lot of code for a teeny tiny two fields object. And when you work, with a real application, instead of like a two fields object, you most likely have 10 fields object or 25 field object, and with a lot of nested structures. So almost no one would write this kind of stuff by hand. And in front end, no, not in front end, in programming in general, when someone doesn't want to do something, what does it do? Yes, an abstraction, a library. Yes. So I want to talk about different libraries that provides a JSON validation, about its pros and cons. And then I'm going to move to my approach. So the first thing, the first, I guess, class of the libraries I'm going to talk about is just the JS libraries. I call them JS libraries because they don't have anything specific to a TypeScript. They just validate the JSON. And the other classes would be somehow connected to the types itself. So the second would be info-based. It's an approach from a function languages where instead of having a type and some validation on top of it, we have the validator, and we derive the type from the validator itself. The third would be decorator-based. A couple of minutes ago, the folks are talking about Angular and Nest.js and using the decorators. So there is one library called Class Validator that does this approach. It's based on the decorators, and so you validate, you slap some decorator on top of the class, and you just then call a function to validate it. And the fourth, well, not so secret solution is a solution I'm going to talk about. So, but first of all, if you have some kind of API specification, you have a Swagger, you have, for example, a protobuf instead of a JSON or a GraphQL API, you don't have this problem, because either the validation of the talking with a server, with a backend, are already baked in. For example, in protobuf it is, or you already have a specification of what endpoints accept what types and return what types and what objects and what's inside this objects. So in this case, you could generate your validation code based on this specification. So if you have this, you don't have this problem, and you should just generate the validation. But a lot of people I was talking about, for some reasons they don't have it. For example, we on our workplace, we don't have it. Our backend's mostly written in PHP, and we have plans to support an open API and the Swagger, but it's not there yet. So we need to do something in the meantime. So let's get back to the library, shall we? So first of all, JS libraries. The biggest pro is that it's simple. You just get a library, describes the validator, calls the validate function, and that's it. The problem is when you have some static typing solutions like TypeScript or Flow, you need to keep in sync the types and the validator itself. Let me illustrate what is this problem I'm talking about. So imagine we have the same task with the title and ID, and we have some method that gets the task from the server. We get this task and just print out the title to the console. Okay, sounds great, but then application evolves, some time passes, and you encounter yourself in a situation where you need to add another field. And so you added an author ID, so the one who created this task. You also can print it to the console, and that's pretty simple. But imagine we have validation. So let's get back to the times where we don't have an author ID, but we have the validation. So in this case, I'm using a library called Superstruct. I like this JSON library because it's pretty small and it provides a readable error messages. So it's pretty great in my opinion. So we import this library. We describe the validator, so it's superstruct.object, and the title is superstruct.string, and the ID is superstruct.number. So it provides some runtime objects that will be in the runtime when we call the validate function, or in the case of Superstruct, it's assert. So as you can see in the get task implementation. And yeah, basically that's it. Pretty simple, right? Then we need to add an author ID. And that requires us to add it into the two places. First of all is the task type itself, and then the validator. Of course, this example is contrived, and it's pretty simple. So it's not that it's that easy to do this mistake and forget to add it somewhere. But of course, you can understand that in a real application where there is a lot of code and the types and the validator are not necessarily in one place, it's easy to let some error slide in the code base. Of course, it won't be as you add the field to the validator, but you forgot to add it to the type, because if you forgot to add it to the type, then the next time you write in task.authorID, TypeScript will complain. But it's pretty easy to forget to add it to the validator itself. So in this case, your code base would be thinking about one stuff. This validator will be almost completely different stuff. So in this case, you end up in a situation where I guess you don't validate at all, because you validate different things that you're using actually. So this is a problem. And there is several different types of approaches that tries to fight it. First of all, it's this info-based. I know a lot of libraries that support this method, IOTS, typed contracts, run types. Even the superstruct library I was showing you on the previous slide also supports this method right now with a new version. So it's kind of ironic. In this case, everything is in sync because you describe the validator and you derive the type based on this validator. It uses a lot of complex TypeScript functions like infer, condition types, and so on and so forth. But from the user perspective, it's more simple, basically. The problem is when you already have an application where you have a validation, where at least you have some existing types that you described by hand, it's harder to integrate it because you still need to write the validator first and then derive the type based on it. And in case you have some complex types using discriminated unions or something like this, you may find it hard to understand how actually to describe that in the library you're using. It's not that it's impossible, but it's still more work on top of what you already can achieve with our solutions. Let me illustrate you how it works actually. So I'm going to go with an example of IETS. It's a library that relies heavily on the functional programming abstractions and category theory actually. But I'm going to save you from trying to understand this kind of stuff. Most of the stuff you see will be pretty similar to what you're already seeing with the superstruct. So we import this IOTS, and we describe the validator. T.type, T.string, T.number. It's not the TypeScript types, it's runtime objects, actually, as the same as in the superstruct. And then instead of insert, you call task.decode. And it returns you an either object. So if it will be either a JSON, validated JSON, or an error. So pretty simple. If you want to get a type that has a title string and ID number, you do this. T.type of, and in the stuff, you do type of task. So it looks pretty complex if you're not familiar with this generics and type of, but most of the time you just write it and it just works. If you go to the definition of a type of, then the complex stuff happens. But you could just not do this for now. And so this is a task type. It has title and ID with the right types. And so if we want to add a new field, we just add a new field in one place. So one source of truth. And it will be automatically that right now the task type with this type of has the author ID type. So pretty great. The next thing I want to talk about is creator-based. I only know one library that does this. It's called Class Validator. Previously, as I understand, it was developed by a TypeStack company, but now when I Google it, I get a link to the fork. So I guess the company stopped supporting it, but some people from the open source just came in and is supporting it now. I don't know what will happen to this library, so yeah, be cautious, I guess. The great thing about it is that the classes are also runtime objects and also at the same time in type. So you don't have this problem anymore. So it's in sync with the classes, and the classes are already in runtime, and the classes can be used as types. So you have a class, you get some decorators on top of the fields, and then you can validate this. But everything needs to be a class, obviously. Personally, I'm not a fan of classes. I'm more of a fan of functional approaches. So I don't like where everything needs to be a class, while it's don't need to. I need a simple type or a simple interface with just two fields, I still need to use a class. But if you're okay with this approach, or for example, you are a decorator fan, you use Angular, you use Nest.js or something like this, I guess it would be great for you. It still uses this experimental decorators option. It's called experimental for a reason. And right now, as I've checked, the decorators proposal is still in stage 2. So stage 4 will be the last stage. And it's already gone somehow from the versions that right now supports is supported in TypeScript compiler. I don't think it's, this kind of support is going to be just gone in a minute, because we already have Angular, we already have Nest. So, but also you need to be cautious about it. Be aware that the decorators proposal is going to be different from the experimental decorators in the TypeScript. Also in the Babel plugin, I guess it calls legacy option. I don't remember exactly. But let's just see. Yeah, one small problem is that the decorators are limited in a way that they can't really use the type of a field. I mean, they can use it, but it's limited in a sense they only get a string representation of the type. If it's string or number, it's okay. If it's some interface, they only get the name of the interface. They cannot read the fields. So it means that even if you have a string field, you still need to add a string decorator on top of it. Let me illustrate it. So we have this class task. We have the constructor with title and ID. And as you can see, there's this is string decorator on top of the title, and is integer, is int, on top of an ID. And so it's basically the same. You create this class, and you pass it to the validate function. In case of class validator, it's validate. And yes, that's it. That's almost the same. And so if we want to add a new field, you add a new field to the class, you add a decorator. I also added it to the constructor, but it's just an implementation detail. You could just easily go, without it. And it's basically the same validate. So yeah, that was it for existing solutions. And right now I want to talk more about my solution, finally. It's a different approach, and it's called type-directed emit with custom transformers. So type-directed emit, it's basically when your types somehow affecting the emit. This is the bending reality part. And with custom transformers, basically custom transformer to a TypeScript is basically like a Babel plugin to a Babel. Just a little bit different. But what they do have, they have an ability to read the types, actually, because Babel doesn't know about types. I mean, it does know that this, if you have a colon, then they're going to be a type. But the Babel doesn't understand what is this type, what field does it have, what types of these fields, while TypeScript does. And it can also affect emit somehow with this custom transformer option. Okay, so let me show you how it will look like. So we have like the same-ish code from before. We have a type task with a title and ID, and we have this get task function that goes to the server and then converts the response to a JSON. And as a programmer, what you do, you input the validate function from a package called superstruct ts transformer, whatever, I don't know what this package is. And then you write it then and call this validate function, passing JSON as a first argument, but also passing task as a generic argument. So you're passing not only a JSON as a runtime thing, but you're also passing a type, this type task with title and ID. And that's what you do. That's it. But what will happen afterwards when you compile it? So what will happen with this? First of all, the input would change. There will be no validate function. Instead, it will import this superstruct library I've shown you before. Then the validate call will change in a sense that this generic argument will disappear, but reappear on the name of the function itself. So right now, the function will be validate_task. And the implementation of this function will also appear. And in the implementation of this function, we'll accept this JSON. We call it superstruct.assert. Basically, the same assert that we've called before. And then we describe the thing with an object and a string and a number, almost the same as we also did before, and validate the JSON, and then return it if it doesn't throw an error. So what's happened is that we find this validate function. We go to the task type. We read that it has a title of a type string, an ID of a type number, and we generate this code for you. And then generate basically this function. So that's the magic. And it can also, work with the nested objects, with the unions, with the intersections, and pretty much everything you can describe in type, you could also describe it as this validator. So yeah, this is the thing. It also supports custom validation. I'm going to go a little bit inside some complex TypeScript stuff for now. So if it doesn't make sense right now, it's okay. I spent a lot of time learning TypeScript, but the thing is, even if it doesn't make sense right now, the next time, the second time, the third time you're going to read about this like branded types or something like this, it's going to make sense finally, because the brain will find, make the connections and process that information. So the thing is, you can only go so far with the types as the types allows you. So in the types, we'll have strings, numbers, booleans. But what if you have like a special string or a special number? The JavaScript and the TypeScript doesn't have an understanding, for example, of an integer numbers. Of course, we have this typed arrays like int8 array or something like this, but the arrays of this type. And if you want to just say, okay, I have this field, it's an integer. It's not just a number, it's an integer, or maybe even like a positive integer. You cannot easily do this with types. I still can do this, but it's pretty complex. What you can do, you can create a special unique type, which behaves, for example, like a number or like a string in my example. So you can call all of this toString methods. You can call substring. You can call you can turn it into an array. Basically, everything you can do with the string, but not any string will be assignable to this type. So imagine we want to validate an UUID. UUID have a strict rules of how is actually working. So I have this regular expression in here, and it describes this type UUID as a string. So it's basically a string. And this magical stuff, read-only underscore brand unique symbol. What does it make right now for us? It's that if the function will accept this UUID, you cannot just pass any string. this string has to be UUID in the first place. And we have this const is UUID. It's called a user-defined type guard, and it's a predicate that returns true or false. And if you call it, the TypeScript will understand that the value is what it's written. So after the colon, there is value is UUID. If we call this function inside an if, so inside this if block, the value will be of the type UUID. But it's also beneficial for us because with this read-only brand unique symbol, TypeScript compiler API also distinguishes this from all other string types. Because if you just write type UUID string, TypeScript compiler will see this as just string because it's a type alias. But right now it's a unique type, it's string and this read-only brand. And how we can use it inside of our validation is that we can pass this, call this validate function, pass the JSON pass result to it, and as a second argument, I passing the is UUID function. And what will happen is that it will find that the type of the field is UUID, and it has a function that checks that the value is UUID. And it will call this function, and basically the validation will result based on if this function returns true or false. So that's pretty neat. I haven't found any talks about branded types, but I do have a bunch of articles about it. I guess I'm gonna send it to the chat if I will have some time. So another thing, so I've cut the most hardcore part of my talk. It was about the implementation detail of this transformer, so like reading the IST, working with the compiler API. But I do have a bunch of talks that will help you to get to the IST and like a Babel plugins. So, oh no, where is this? Oh, okay, sorry. I mixed the slides. So the first video I'm going to talk about is the art of the AST. It's a pretty good talk. It only takes about 30-something minutes. Another talk I want to present to you, I guess some of you may know this person. It's Nicola Ribaldo, and he talks about how to use Babel, and he live coding the Babel plugin that allows for translation of this Elvis operator like question mark dot on the stage. I'm also a part of the program committee of the Russian conference HolyJS. And so we like Nicola. I guess Nicola also likes us. So we have another talk from him. It's called Babel Error Factoring Tool. And in this talk, he research and basically uses the Babel as a code mode tool. So if you want to get into the code modes and how you can use Babel for it, please go ahead. I will send these links and the links to the presentation in the chat. So I need to get back a bit. Yeah, so that was for the custom validation. The problem is with this approach, with a custom transformer, you can't use Babel RC because it's a different stuff. And TypeScript doesn't support any plugins in the text file. So we have this tsconfig.json, but it doesn't allow plugins to be listed in here. So with the Babel, we have this Babel RC. With the TypeScript, we don't have this. Well, we do have, and Most of the plugins for a Webpack, for a TS node, already supports a programming interface, so you can pass this custom transformer with a programming way. And there is a tool called TypeScript. So instead of TSC, it will be TTSC CLI, and it does support analog to the Babel RC, but still it's harder to do this. But good news is I have plans to have actually a Babel plugin talking with a compiler, TypeScript compiler API. So in this case, you will just add a Babel plugin, and that would be it. Other application of this approach, like taking types and doing something with compiled code, would be, for instance, prop type generation. So when you migrate from, prop types, it's a React library for validating the properties of a component. It's a runtime validation library. And most of the time when you migrate to the TypeScript, you just get rid of the prop types, and instead of describe the types in the TypeScript. And essentially having prop types and the TypeScript types, it's having the same problem with JSON. So one validator here and one type here, you need to keep them in sync. But prop types are still useful because they allow you to detect where your types actually lie about your code base. So when you describe that the type should be this, but in fact, in the runtime, you're passing a wrong object, or don't pass anything at all because you forgot it, or because you're still in the process of migrating the code base, so you pass it from the JS file, and the TypeScript doesn't complain here. So if you can generate the prop types based on the prop type of a component, this would be great. And I've seen libraries that do it. One time I had an application for a data stub generation. So at this time, I didn't know anything about this stuff, and I needed to do a mock server. Pretty simple one. I just wrote it manually, like took some Express and a library called Faker that allows to generate the fake data. It's more advanced than just generating strings and booleans, because it can generate, like usernames, dates, addresses, emails, and stuff. But thing is, this mock server didn't live a long time because, I still have to like backport all the functionality from the real server. But it may have helped if I had a library that allows me to generate fake data based on the type. Of course, right now, what I would do is I would do a backend with a Swagger API specification. And there is solutions that allows you to generate a whole like mock server based on this specification, not only its data. But yeah. And the last thing is the property-based testing. So the property-based testing is a technique where your test doesn't rely on hard-coded data, but instead of should work with random data. Actually, it's not gonna be for all of the tests, but for some of them. And what I thought is that it has some kind of like a generator for strings or numbers, and we can do the same stuff. So instead of just writing it manually, we could, pass the type and select the generator based on this type. I don't know if it's makes sense or not, but yeah, I just thought about it. So this is the JSD talks, and basically that's all I wanted to talk about with you right now. There is a links to the library itself. TS Type Visitor is an implementation detail, but it's basically a library that converts the types from TypeScript compiler API to more readable form, actually, because TypeScript compiler API is it's not really easy to work with. There is a link to my Twitter. Most likely, my handle in most of the social networks would be Saito Nakamura. Maybe not in Facebook, but in Telegram and Twitter, yes. I'm mostly active in here. And the link to the presentation itself. I'm gonna send it to the chat. Yeah. Yes. Oh, okay. I should have copied the link. But yeah, so I guess that's it. Maybe we have some questions from the audience.
Okay, I'm here. So thank you, first of all, thank you, Michael, for the very nice presentation. Yes, please, audience, if anything comes to your mind, do not hesitate to ask the question in the chat or in the QA section. And yeah, let's just start with like, I was really like curious because of course there are like this kind of topic is like present in most of the projects, right? Whenever you have like a front end and a back end, you kind of want to make sure that these things stay in sync. So there are various approaches to do that. So, and this is why I would like to ask, like, what would be like the best constellation of all the circumstances when this approach shines like the most? What is like the perfect use case or like a perfect environment when this brings the most value, so those people don't even have to think about it and just can install and grab your library and start using it and get all these benefits?
So the best environment I can think of is that when you have already a TypeScript code base with the types that you describe manually, so you don't have a specification, and you don't have any validation, and you want to add a validation on top of it. So in this case, it would be as easy as just a little bit more complex than adding Babel plugin, but still pretty easy, and just call this validate functions.
Exactly. So that means like if people already have like pretty nicely typed code base with the interfaces or types, then they can just install the library. And then as I can see, like basically import that validate function and pass your own type as a generic to it. And then all this will be emitted during the build process. So it will just happen for you, right?
Yes, it still has some limitations. For example, it has a problem where you can wrap a function or can wrap this validate function with another function that accepts a generic, because it's a pretty big problem how to approach it. Right now, it just doesn't allow it. It will throw an error if you do this, but I know how to solve it. I just didn't have time to actually implement it because it will require at least to go through the AST.
I see. Yeah, that's the common topic, right? Like, so there is like so many great ideas, but they has only 24 hours and there is just so many things to do, but slowly,
Exactly.
stuff just keep coming. No, that's really cool. One thing which comes to mind, because usually like in the projects where we were like in control of both front end and back end, that means it was like some product of the organization or whatever like this. So we're not really consuming like some third party stuff. Then often what we tried to do is to, if it was either monorepo or even like not really just multiple repo, like have either like in the monorepo like a library, or then like a library which is deployed with some types, which then was then consumed by both the front end and the back end, which kind of then allowed it to at least like this most like rough level validation that those properties are there, which ones are optional, which type should it be, right? So how does this compare like with your approach? What is there missing? What's the difference?
Maybe I didn't understand your situation. Yeah. Could you explain it a bit more?
Of course, please. So imagine we have, let's say, a front end and a back end. Let's say the back end is in Java, and then there are like these also utilities which can, for example, generate d.ts files from the Java DTO classes, right? So, and then if you can consume that as a npm package, for example, in your frontend, which was deployed to like a organization Nexus or something like this, and that way you can be sure that like those things which is gonna be sent from the backend because they are fulfilling like those Java DTO classes because they kind of have to because it's Java, you will expect that and you will get that like as a types from the DTS in your front end.
Okay, yeah.
So at least
Understood.
this level of validation in terms of like property names, property types will be there, right?
So yeah, if you can afford this, if you will have a backend in the static type languages such as .NET or Java, just go for it. It's great. It doesn't require a lot of maintenance. But there is one problem still. This output data, so you've generated this typing from the Java, but you can't make sure actually that you're talking to the backend which has the same version that you are. You can't actually make sure that it doesn't have any bugs or something like this. So if it's still critical for you to understand that the data coming for you from the outside that you can't control actually, you still may want to do this validation, but just if you have this DTS files, that means you can also generate the validation based on the data that allowed the generation of these DTS files in the first place. And it's much easier just to do this than to have these types and then pass it to the custom transformer. It's just an extra step in this case.
Yeah, this makes perfect sense, like, because as you said, like there is so many other steps which could go wrong. So even if you have this in place, maybe like the version is mismatched or something goes wrong with the pipeline, so you don't get the latest version and stuff like that. But then, of course, like in your presentation, you show that your approach can do more than that, right? Because this kind of sharing of the type is like, okay, is it optional? Is it not? Is it number? Is it string? But then you showed that you can do actually like even more complex type guards, right? For example, in your example, there was like a UUID, which is already, I think, like a next step on top of that, which you could not achieve with that like proposed mechanism, right? So that would be also something like what is like the limitation of the complexity to which you can implement those type guards? Like how fancy you can get, what can you validate?
Actually, you can validate basically anything, because the only limitation of this type guard is that it's a predicate, so it needs to return true or false. But there is also a way to provide an error message. It's not implemented right now, but it can be. So inside of this validate function, you can do whatever you want. And with some libraries, you can even implement an asynchronous validation. So it will await instead of just executing some synchronous code. So you can just go crazy in here. The next step would be to also convert the data. This is an interesting stuff, because, for instance, if you have a date string in the ISO 8601, you may want to convert it to date object or to, I don't know, date FNS object just on the fly when you actually decode the data. And this would be pretty cool. I know it's supported by the superstruct itself. It's not supported by my library, and I still don't know how to actually describe it and express it in types, but that will be the next step that allows for more crazy stuff on top of it.
Let's say that it's on the roadmap, that you are already actively thinking about it.
Yeah, I guess.
So we have another question, which is a bit tricky one. Have you already used this in a production?
Well, that is a tricky question because I have not. Right now, I'm in the process of trying to integrate this solution to our code base, because we have this situation where we plan to have a Swagger API, but it's still in the works, and I don't know how much it will take. And we already can benefit from it, from validating the JSON, but yeah, you can only go so far trying to implement good software code base. So I haven't done this yet, but I have an extensible set of unit tests that test this library, and I also used it in my pet project. So yeah, I found a few bugs when I was, actually implemented it, not testing it with a unit test, but in the real world use case.
Sounds good. I mean, like, of course, like over time, all these things, like the more users they have, the more bugs are found, and it will be like a natural evolution. So it looks like we do not have any more questions, and anyway, we are kind of right on time this time. So then please, Michael, let me thank you again for a very interesting talk. Wish you all the best with your library, and hopefully to see you again at some next edition of the JSday Italy next time.
Yes, thank you for having me. It was great.
Have a great day. Ciao, ciao.